Hey guys, welcome back to Eureka, and in this video I'm going to be doing some basic questions for the periodic of mechanics week 7, right? So let's start with question number 3. It tells you express as a bearing, and then they give you A, B, C, D, whatever. First of all, let's review the concept of a bearing. You have the XY coordinates, and they tell you you have a bearing of 120. So you take the north and then you go 120 degrees, right? So you're going to be left with 60 over here, right? Because 90 plus 30 is 120. That is exactly what bearing is. Let me give you another example of bearing. Let's say you have bearing of 300. Well, bearing of 300 is going to be this angle. This is going to be 30, right? This is 90, this is 90, this is 90, and this is 30. 90 plus 90 plus 90 plus 30 is equal to 300 degrees, right? So you always go from the y-axis and you go clockwise. That's the definition of a bearing, right? So now let's do part A. They're telling you have N 50 east. This is a mariner's compass, so let's draw it. You have north, east, south, west. North, east, 50 degrees, literally means you go from here to here, 50. From the north to the east side, 50 degrees. They want you to express that in bearing. Well, to be honest, it's the same thing. North 50 east is just 50 bearing. Okay, let's do B. In B, I'm going to go a bit faster. In B, they tell you have south, 32 west, right? So you're at south, and you go towards west, 32 degrees. And they want us to express that in bearing. Bearing is the clockwise angle, so it's going to be this. This angle plus this angle plus this angle. So 90 plus 90 plus 32. And that's our answer. You want to use a calculator, you're going to get, I believe you're going to get 212. So the bearing is 212, right? Now let me give you another example, part C. Part C tells you south, east 40. So you have south and you have east. You go from south towards east for 40 degrees. South 40 east. You go from south to east 40 degrees, right? You want to express that in bearing? Well, it's going to be this angle or this angle. This angle is going to be 90 plus this angle is going to be 50, right? Because 90 minus 40 is 50. So your bearing is going to be 90 plus 50, which is 140. I think that's enough. Let's move on to the next question. Question number 4. Express using the mariner's compass a bearing of 90 degrees. It's like the other question. You have a bearing of 90, so this is your bearing. You want to express that in mariner's compass, northeast, southwest. Well, it's going to be the exact same thing as saying take north as the origin, go 90 degrees towards east. Okay? Part B. Part B, they say you have a bearing of 120. A bearing of 120. A bearing of 120 looks like this, right? Where this is 30 degrees. 90 plus 90 plus 30 is 120. How might we express this in the mariner's compass? Well, you can either say southwest by 30, or you can say west, south, 60, right? South, west by 30 degrees, or west, south by 60 degrees, right? Let's move on to part C. Easy questions. I'm going to be doing them really quickly, so we have time. You have a bearing of 180 degrees. You want to, put that as mariner's compass. So north, south, oh my god. Wow. Northeast, south, west, right? North is here, and it goes out a bearing of 180 degrees. You can say due south and that would be 180 degrees bearing. Or you can say east, south, 90 degrees, right? From east to south by 90 degrees. Or you can simply say due south. Moving on. A bearing of 340, right? So a bearing of 340 is going to be something like this. From here to here, you're going to be left with 70 degrees here, right? Because 90 plus 90 plus 90 plus 70 is 340. Let's just check on the calculator, and yes. So that's your bearing right there. How might you express that as mariner's compass? So we know that this is west and this is north. You can either say west to north by 70 degrees, or you can say north to west by 20 degrees, right? Because from north to west, that's 20 degrees. Right, that's enough with bearings and mariner's compass. Let's move on to number 5. Number 5, they're telling you find the position vector of A if it's 8 units away from the origin at a bearing of 120 degrees, right? So first of all, let's find the bearing. So it's at a bearing of 120, so this angle is going to be 30, and it's going to be 8 units away from the origin. Here's the origin. Here is, let's assume that this is 8. This is your position vector of A. 8 units away from the origin. Let's move along. Then they're telling you, oh, question 5 is done. Moving on, question 6. So question 6 and question 7, pay attention because you guys asked a lot about this question. They're telling you have a position vector A. It has a magnitude. So you have a position vector A and its magnitude. The absolute value means magnitude, right? Its magnitude is 8 kilometers. Its direction is north 30 east, right? And then they're telling you have a position vector B. Its magnitude is equal to 20 kilometers, and it has a bearing. Its direction is bearing 300 degrees, right? They're telling you find A plus B, express it in I and J, right? So let's draw the graph for this. You have a graph like this. A is north 30 east, right? So here's north, here's east. North 30 east is like this. A is somewhere here, right? That's A. It has a magnitude of 8. That just means that the line's distance, like this whole distance right here, is 8. So that's A. Let's change color. Let's draw B. B is bearing of 300. Now, bearing of 300, you know how to find bearing. Go clockwise. You'll end up over here with 30 degrees, right? B, magnitude of 20. Here's B. They're telling you find A plus B, right? Well, here we go. Let's go. This angle is 60, right? You can say that. So let A be in red. A is equal to 8 multiplied by, so you know that the x coordinate is going to be cosine of something and the y coordinate is sine of something, right? Well, look here. The y coordinate of A, which is this line, is sine 60, and of course there's a j, and the x coordinate, which is this, is cosine 60, and you have an I. That's basically vector A. Let's find vector B. Let me change the color. Vector B. It's equal to, you multiply the magnitude by the vector. The x coordinate is cosine something. The y coordinate is sine something. And of course you have j and you have I, right? Look here. The y coordinate of B is sine 30, right? And the x coordinate, which is this, is cosine 30. But the thing is here, B is in the second quadrant, right? Here's the second quadrant, here's the third quadrant, here's the fourth quadrant, and here's the first quadrant, yeah? In the second quadrant, x is negative. Here's -1, here's -2, so on and so forth. So the x value is negative cosine 30i. So if I were to rewrite this as minus cosine 30i. And now we can do simple mathematics. They want us to find a plus b. Well, that's just like saying 8 cosine 60. Let me write it in better handwriting because people complain about handwritings all the time. 60i plus 8 sine 60j. That's the equation for a, right? Minus 20 cosine 30i plus 20 sine 30 j, right? Well, that's your answer. If you want, we can further simplify it on a calculator. 8 cosine 60 minus, so here we go, 8 cosine 60 minus 20 cosine 30 is going to give you 4 minus radical 10. So 4 minus 10 radical 3 I plus, and the b coordinate, the y coordinate is going to be 8 sine 60 plus 20 sine 30, right? And you're going to get 10 plus 4 radical 3 j. If you want to further simplify this, we're going to get, so 4 minus 10 radical 3 is negative 13.3. Negative 13.3. That's I. Plus 10 plus 4 radical 3. Let's simplify that. We get around 17j. Around. And, well, not 7. It's 16.9. 16.9. Keep it in 3 significant figures. And there you go. That's our answer. Moving on. Done with question 6. Let's move on to question 7. It tells you have a point A, and it has a position vector of magnitude 15, and it's 30 degrees southwest. So it goes from south to west at 30 degrees. So let's draw this. From south to west at 30 degrees, right? And it has a magnitude of 15. This is point A. So this is vector A, right? And then they tell you you have a point B, magnitude of 10, on a bearing of 120. So this angle is 30. This is B, and it has a magnitude of 10. Vector B, right? Now they're telling you find AB. So find AB. In the question they used capital A, capital B. It doesn't matter. I put it in lowercase. So what does this mean? AB. AB means, so here's vector A, here's vector B, right? They want this vector, A, B. Now let's use the triangle rule. You have two vectors that go like this, yeah? If you want to find this vector, we're going to have to flip this vector. So it's going to look like this, yeah? So this is going to be like this. This plus this will give you this, right? So if this is A, this is minus A, right? So we're going to have to flip this vector, and it's going to have to look like this. Same magnitude of 15, but now it's minus A. So what we're actually trying to find is minus A plus B, right? So how do we find minus A plus B? Well, first of all, we have to find the equation of A, we have to find the equation of B, and we simply have to minus A and add them up, right? So here we go. Let's find the equation of A. Let me redraw all of this. A is like this, B is like this, and this is 30 degrees, this is 30 degrees, this is A, this is B. Param param, param param. and this is 15, this is 10. Let's draw this. A is in the third quadrant. That means the x value and the y value are negative, right? This is -4, for example, and this is -4. The y and x values are negative. So sine 30, actually, so I won't confuse you, we're just going to keep it as cosine. So this angle is going to be 60 degrees, right? So sine 60 will give you the y value. Sine 60j will give you the y value, and there's a minus. And cosine 60i should give you the x value, right? And they're minus because they're in the third quadrant. This is A, right? This is A. B is going to be equal to the magnitude multiplied by, as you can see, this is the y value. The y value is sine 30. And of course, there's a j. And from looking at it, you can say that the y value is negative and the x value is positive. Because this axis is negative, this axis is positive, right? And this is B. Now what we're trying to find is minus A plus B. So minus A is going to be minus 15 into minus cosine 60 I minus 60j, right? This is equal to 15 multiplied by cosine 60. We just distribute the negative plus sine 60 j. Okay, this is A. This is minus A. This is minus A. And now we need to sum this and this up, right? So let's sum them up. So we're going to get 15 cosine 60i plus 15 sine 60j. Let's go up. That's minus A, and this is B. B is going to be plus 10 cosine 30 I minus 10 sine 30j. Right? Now we're going to do some calculator magic. We're going to end up with something like, so give me a second, calculator magic coming up. So we're going to get 15 plus 10 radical 3 over 2 I, and we're going to get, for j, we're going to get 15 sine 60 minus 10 sine 30. We're going to get this, so plus minus 10 plus 15 radical 3 over 2j, right? Now again, let's use some calculator magic and let's simplify. This is going to be 7.99j, and this is going to be, give me a second, 15 plus 10 radical 3, 16.16i. That's your final answer. So now that we're done with question 7, let's move along. Let's go to question 8. Question 8, they're telling you a point B is 4 units away from the origin at a point at a bearing 210. Right? So let's draw it. Bearing 210 would look like this. Right? 210. So here, 180 plus 30 is 210. So 30 degrees are left. Right? And this is B. Magnitude 4. If B is the position vector of, so yeah, B is the position vector of big B. That doesn't really matter. Find the parametric equation of a line that has the same direction as this vector and it passes through A. Now here's the thing. They have to give you the value of A in order for you to do this. And the value of A is given to be 5i minus 6j. They're telling you, you have to find a line who passes through this vector and is parallel to this vector, right? So A looks something, by the way, I'm not going to solve it entirely. So the first method of doing it is literally saying A plus K, oh my god, A plus K be vector. This is how you would do it in the exam to save yourself time. You would say A plus some constant K multiplied by B. But if you want the actual explanation, so let me substitute. So 5i minus 6j plus k into b. Let's find the equation of b. b is equal to 4 multiplied by cosine 60, and obviously, actually, cosine 60 minus sine 60, right? J and I. That's the value of b. So let's substitute that. We're going to get 5i minus 6j plus 4 into minus cosine 60 I minus sine 60j. This is your answer. You can simplify it using a calculator. But now let me try to explain how I got that answer. Right? Let me try and explain it. So the thing is, when you have two vectors and you're trying to create a line, and one of them, like one of the vectors, the tip of it has to pass through that line or has to be in that line. So A is going to be 5i, and let me look over the question. 5i and minus 6j. So here's minus 6, right? So here's the vector A. And you have another vector B that looks like this. They're trying to tell you find the line that passes through this point and is parallel to this vector. Now look at this. Let's add A with B. What's A plus B? So this should create a line that it should create a vector like this, and it's parallel to B, right? A plus B looks like this. Now, if you multiply B by K, then the tip of B would either be here, 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 here. It goes along. It depends on K. K could be 1, could be 2, could be 0.3, could be minus 4, so on and so forth. K could be any of those numbers. As K varies between these numbers, on and on and on, the tip of vector B would vary along this line. See this line? This line is parallel to B. Now this is what we did by drawing a vector. So what we just did is we added two vectors and we made a third vector draw a line. If I could, add an animation, I would, but I can't. You can imagine the sum of A and B passing along every single point here and here. So that's question 8 done. Let's go to question 12. I told you I'm not going to be doing everything. I'm just going to be doing the so-called hard questions. So question 12, they're telling you have two forces, F1 and F2. Find the magnitude and the direction of F1 and F2 if you were to add them. Okay, this is simple vector addition. F1 is 7i plus 9j. N means Newton, forget about it. If it came in the written, then write Newton. If it didn't, then don't write Newton. 8i minus 12j. They're telling you, find the resultant of F1 and F2. So find F1 plus F2. This is the resultant, 7i plus 9j plus 8i minus 12j, right? Let's add them. We get 15i minus 3j. That's the resultant. And then they're telling you the direction. How do we find the direction? First of all, this is F1 plus F2. The magnitude of F1 and F2, this is the magnitude, 15 squared plus minus 3 squared, right? Let's do that. On a calculator, we shall get 3 radical 26. That's your magnitude. And now, let's continue. How do you find the direction of the resultant? The direction of their resultant is going to be arctangent minus 3 over 15. Y over x, right? This is the y component, this is the x component. Doing that on a calculator is going to give you, so minus 3 over 15, it's going to give you minus 11. Minus 11. Minus 11.3, so on. I rounded it to two significant figures, so minus 11. Now, how do we change that into normal angles? So if you look at this, this is minus 3 and this is 15. So x is positive and y is negative. So your angle is somewhere here, and this angle is 11, yeah? So if you want to change it to bearing, it's going to be 90 plus 11. If you want to change it to mariner's compass, it's going to be east, 11, south. That's your direction. Let's move along. Question number 13. Now this question might mess you all up. I'm expecting it to mess you all up because, you know, Sabas knows how to make students fail. So you have a rectangular coordinate system. That just means you have the x and y system. I is the unit vector along the x and j is along the y. Whatever. You have point A, point B, and point C. They're giving you the coordinates. Then they're telling you find the parametric vector equation of a line R. Basically, they're telling you find the equation of a line in terms of vectors. And that vector, that line, passes through point A and the midpoint of BC. So here we have point A. Point A is minus 1 and 5. And we need to have another vector, which is BC over 2, the midpoint of BC, right? In order for us to find the midpoint of BC, let's draw it. Let's say that this is vector BC. Let's say you had, for example, this is not related to the question. I'm just giving you a general idea. You had BC. Let's say that this is their midpoint. If this is vector BC, the midpoint of BC is M. The position vector of the midpoint would look like this, OM. And this would be OB. This would be OC. Right? So what we're going to try to find is, we're going to try to find point M. Let's find it. So let me draw. You have B of coordinates 3 and 6. You have C of coordinates minus 1 and minus 2, right? How do you find their midpoint? Well, you say x1 plus x2 over 2. This is going to be the coordinate of their midpoint. And you're going to get, so x plus x is going to be 2 over 2, which is just a 1. And y plus y is going to be 4 over 2, which is a 2. So their midpoint is at point 1, 2, right? So the position vector would look like this. You have 1 here. Let's draw this in a better fashion. You have 1 there and you have 2 there, right? So the position vector of the midpoint would look something like this. And BC, B is at 3, 6. So here's 3. Here's 6. So that's B, right? And C is at point minus 1, minus 2. So C is somewhere along here. So it doesn't look like a line. But let's just assume that these 2 points join perfectly. Let's say that B is here. This is their midpoint. This is what we just found. So the equation of the coordinate of the midpoint is going to be 1, 2. So now we have 2 points. We have A and we have the midpoint. The midpoint is 1, 2. A is minus 1 and 5. Now they're telling you, find the line that passes through these 2 vectors. Well, we know that if we have 2 vectors, the line that passes by them is just going to be the first vector plus some constant multiplied by the second vector minus the first vector. Or you can rewrite this in another way. You can say, using mid plus k into A minus mid. And this is literally our answer. In the video, I'm going to be using this vector equation, and we're going to be discarding the second one, although they give the same exact outcome. So here we go. So the position vector of A is, is minus I plus 5j. And that's going to be plus k into, now what's mid? Mid is just going to be I plus 2j, right? That's going to be mid, minus, and minus a. It's going to be minus I plus 5j. And of course they're multiplied by some constant k. If you were to simplify this, you're going to get the answer. I'm not going to simplify it in the video because it's simple math. I'm really sorry, but we're going to be running out of time really soon. So let's do the last question on chapter 1, which is question 14, and this video will be over. I'll be doing basic questions for chapter 2 in a different video. So here we go. Find the vector v of magnitude 8. It has the same direction as vector 1, and vector 1 has magnitude of 4 and is at a bearing of 120. So this is a bearing of 120. They're telling us that you have v1 here and you have another v there. They're telling you that the magnitude of v1 is 4. This whole thing is a 4. And they're telling you the magnitude of big V is 8. Right? So we're going to have to find v in terms of v1. We know that when two vectors are parallel, then they can be written as some constant multiplied by the other. Right? Take this as a rule. When two vectors are parallel, then one of them is equal to some number multiplied by the other. And you can look at it from here actually. 2v1 is equal to v, because 2 times 4 is equal to 8. Right? So all you have to do is divide the magnitude of the bigger vector by the smaller vector. In this case, you'll get a 2. And, well, 2 multiplied by v1 is going to be equal to v. All we have to find is v1, right? So big V is equal to 2 multiplied by v1. Let's draw v1. v1 is a bearing of 120, so this is 30 degrees, and it has a magnitude of 4. Let's find its equation. Its equation is 4 multiplied by cosine minus 30 plus sine minus 30. There's a j here, there's an I here. Okay, here we go. This is equal to v1. Using some calculator magic, we're going to get 4 multiplied by cosine minus 30. Yeah, I'm just going to be using a calculator. You're going to get 2 radical 3i. And 4 sine minus 30 will give you minus 2j. This is equal to v1, right? And we're trying to find twice v1. So our answer is going to be 2 multiplied by 2 radical 3i minus 2j. And that's your answer. You want to simplify, you're going to get 4 radical 3i minus 4j. Thank you guys for watching, and stay tuned for a different video explaining chapter 2 basic questions. And as always, easy.